Einstein once predicted something terrifying. If you could travel at the speed of light, about 300,000 kilometers per second, the universe in front of you wouldn't just move. It would collapse, space would compress, time would distort, and eventually, time itself would drop to zero. From your perspective, the vast universe would flatten into something like a thin sheet. The moment you start your journey, you've already arrived everywhere. But how fast is light, really? In just 1 second, light can circle Earth 7.5 times. From Earth to the moon, only 1.28 seconds. That means when you look at the moon, you're actually seeing it 1.28 seconds in the past. From the sun to Earth, light takes 8 minutes and 20 seconds. So the sunlight you feel right now was born 8 minutes ago. Even if the sun suddenly vanished, we wouldn't know until 8 minutes later. Now zoom out, the Milky Way galaxy is about 100,000 light years across. Light needs 100,000 years to cross it, but for you, traveling at light speed, that journey takes 0 time. This is the terrifying truth about light speed. It turns unimaginable distances into meaningless numbers, and it erases time itself. Many people wonder, if light speed is so fast, what would you actually see if you could travel that fast? The answer is disturbing. As you accelerate closer and closer to the speed of light, the first thing that breaks is your vision of the universe. Because of relativistic aberration and the Doppler effect, the sky would no longer look normal. At low speeds, stars are scattered evenly across the sky, but near light speed, everything changes. All the stars in front of you would collapse toward a single point. The entire universe ahead would compress into a blinding spot of light. And not just bright, deadly bright. Visible light would shift into ultraviolet, X-rays, even gamma rays. The beautiful starry sky, would turn into a beam of radiation, pointing straight at you. Now look behind you. The opposite happens. All the light stretches, redshifted beyond visibility. Stars fade into infrared, then radio waves until there is nothing left. Complete darkness, no stars, no light, as if the universe behind you has vanished. But it gets worse. This isn't just a visual illusion. Space itself is breaking. According to Einstein's relativity, as your speed increases, space in the direction of motion physically contracts the faster you go. The more extreme it becomes. At light speed, all distance in front of you shrinks to zero. The universe is no longer three-dimensional. It becomes a flat, 2D sheet. Planets, stars, entire galaxies, crushed into paper-thin layers. Distance disappears, depth disappears. Reality itself collapses. Imagine this. You're inside a light-speed ship. In front of you, a blinding wall of lethal light. Behind you, endless, silent darkness. Around you, a universe flattened into nothing. This is what a light-speed traveler would see. Lonely, distorted, and utterly unreal. But the most shocking part? Time is gone. We're taught that time flows normally, second by second, the same everywhere. Einstein proved that's wrong. The faster you move, the slower time passes. This is called time dilation. And at the speed of light, time stops completely. No past, no future, everything frozen in a single moment. And this isn't just theory. We've proven it. There's a particle called the muon. It lives for only 2.2 microseconds. At normal speeds, it should never reach Earth's surface. But moving near light speed, its time slows down, its lifespan stretches, long enough to reach the ground. We've detected it over and over again. Particle accelerators confirm the same thing. This is not speculation. This is reality. Imagine this. You're traveling at 99% the speed of light, heading toward Proxima Centauri, a star 4.2 light years away. From Earth's perspective, your journey takes 4.2 years. But for you, only a few months pass. Time itself slows down. Now push it further. If you could reach 100% the speed of light, something unbelievable happens. From departure to arrival, you experience 0 time. No waiting, no journey. The moment you leave Earth is the moment you arrive. Every distant point in the universe becomes instantly reachable. For light itself, this is reality. A photon is born already moving at light speed. It has no rest mass. It doesn't experience time. For us, sunlight takes 8 minutes and 20 seconds to reach Earth. But for the photon, there is no travel. No duration. Birth and arrival are the same instant from the Big Bang until now. For a photon, it's all just one eternal moment. This is what Einstein meant. At light speed, time ceases to exist. Past, present, and future collapse into one. You wouldn't age. You wouldn't change. You would exist outside of time itself. But here's the brutal truth. There is a cosmic barrier that can never be broken. Any object with mass, no matter how advanced your technology is, can never reach the speed of light, because as you accelerate, your relativistic mass increases. The closer you get to light speed, the heavier you become. At 99.99% of light speed, your mass becomes over 7,000 times greater than at rest, and as you approach light speed, your mass approaches infinity. To accelerate an object with infinite mass, you would need infinite energy, and the universe doesn't have that much energy to give. This means no spaceship, no planet, no human can ever truly reach light speed. Only particles with zero rest mass, like photons and gluons, can naturally travel this fast. This isn't a limitation of technology. It's a rule of reality itself. And what about faster than light travel? Could you go back in time? Change the past? The answer is no, because faster than light motion would break causality. It would mean effects happen. Before their causes, a glass would shatter. Before it's touched, reality would become chaotic. Time would run backward. The entire structure of the universe would collapse, and the energy required would be even more impossible than reaching light speed. So light speed is not just a number. It is a cosmic firewall. It protects the order of time. It prevents paradoxes. It keeps cause and effect intact. And it ensures that the universe doesn't fall into chaos.